2.3, tables, equations, and graphs. So we spent a lot of time on linear equations and using slope-intercept, and that's the most important thing in algebra. You need to understand that completely. That means have it mastered. The other ones we're going to discuss today, we're going to kind of touch on and be introduced to, but you will do them in much greater depth in Algebra 2. You will do them a little bit more in Algebra 1 later in this book and then in the next book, but not quite to the level of the linear equations. You got to have that one mastered. Okay, so we're working on translating between tables, equations, and graphs. You need to be comfortable when I give you a table to come up with the equation and to come up with the graph. You need to be able to, when I give you an equation, to come up with a table and a graph. You need to be able to, when I give you the graph, come up with a table and equation. I hope I said that all right. But you need to be comfortable moving in between them. Okay? When they're linear, as in number 1 red, that will be a straight line like you're used to, and you can use slope-intercept. But sometimes I'm going to give you functions that are not linear. So we're going to talk about 3 different families today: linear, parabolic, or quadratic. The book tends to use the parabolic term. The other term would be quadratic for that. The other function that you will talk about, family of function you will talk about, is inverse. I'm going to take each one down, and when you do your note to self, you're going to want to jot down a lot of these bullet points. So, linear functions. We talked about this in the last unit, but it's good to keep them together as a family because you're going to need to be able to identify which one's which. So, in a linear function, x variable's highest exponent is 1. Remember that the exponent on the x is a 1. It's not there, it's not written, you'll never see it written, but it's a 1, and it's important to know that because you're going to have some instances where they're not 1. Okay, when you graph it, it's a straight line that has a slope, meaning it's steep. So it's either a small slope, which means it's kind of flat, or a really steep slope, which means that the number's high and it's really like if you were to ski down it, it would be like a black diamond. Okay. The other thing about a linear function is that it has consistent, steady growth, meaning it grows by 2. As x grows by 1, it grows by 2. And you'll see that in a few moments. I'll show you that. And then finally, it will fit into the form y equals mx plus b. Do you remember what m is? Do you remember what b is? You need to know that. You need to know that so well that you can memorize it and say it in your sleep. Okay? All right, so let's do this one, 2x plus 4. It was in our last lesson. This should feel easier now. Okay? So remember, y equals mx plus b. I know that m stands for slope, and m matches up with 2. I know that b stands for y-intercept. I could write either, and that would be 4. If I want to graph that, I would come over here, and I would first graph 4, because that's my y-intercept. Okay? Then I would use 2 as my slope. I would think about rise over run. Rise is 2, run is 1. So I rise 2, run 1. Rise 2, run 1. If I want to go backwards, I could drop 2 and go to the left 1, according to the pattern. Okay? Connect my points, and guess what? I have a straight line because I should be using a ruler. So that's the graph of this function, this linear function. The table, of course, I can plug in, or I could just look at my graph. Negative 2 is going to be 0. Negative 1 is going to be 2. 0 is going to be 4. 1 is going to be 6. And 2 is going to be 8. Okay, so now I've got my table, my graph, and my line. The one thing I just want to show you with this is the constant, steady growth. Excuse me, consistent or constant steady growth. So as x goes up by 1, what happens to y? Y goes up by 2. Up by 2 more, up by 2 more, up by 2 more. It's always the same growth. It adds 2, it adds 2 each time. And it is not a coincidence that my slope is 2. What it grows by is the same as its slope. Okay, so you may want to say that. What it grows by is the same as its slope. Okay? Now, let's move on to another family of function. Parabolic or quadratic functions. Okay, these ones are going to be a little bit more difficult. The way you can tell that it's parabolic or quadratic is that the x variable's exponent is a 2. Look at this example. See how it's x squared? Well, anytime you have x squared, you know it's quadratic or parabolic. The graph is what we call a parabola. It's different than parabolic. The way the syllables go are different, but this is called a parabola. And yes, it looks like you want to call it a parabola, but that's not right. Parabola. Okay, I'll show you what that is in a moment. The data that you get when you do your chart is symmetrical data, and the shape is symmetrical. Do you remember what symmetrical means? Well, you will. Typically, this is like the most generic form of the equation. I added 1 here. You could add 7. You could have a coefficient too, but it's going to have an x squared term in it like that. Okay, so what do you do with these? You can't move as comfortably between these as you can a linear function because I haven't really taught you very much about it. So what I'm going to do is I'm going to give you this equation and you're going to fill in the chart. So if I put a negative 2 in for x, I get negative 2 squared plus 1. Negative 2 squared gives me a positive value of 4 plus 1. So y equals 5. Okay, if I put negative 1 in, I get y equals negative 1 squared plus 1. Negative 1 squared gives me a positive value of 1 plus 1, so y equals 2. If I put a 0 in, I get y equals 0 squared plus 1. That's 0 plus 1, so y equals 1. If I put a 1 in, I get y equals 1 squared plus 1. 1 squared is 1, plus 1 is 2. If I put a 2 in, I get y equals 2 squared plus 1. 2 squared is 4, plus 1 is 5. Okay, so I filled out my chart. This one's easy to see. We haven't talked about the parabola, but let's look at symmetrical data. Can you see how I have a 2 and a 2 and a 5 and a 5? It's symmetrical, and this being my center point. All right, well, let's graph it and see what that looks like. I'm going to start with that center point, 0, 1, right here. Y-intercept. Notice y-intercept, and let's highlight our function because it kind of gets lost in my work. That's the function. So the y-intercept is a 1, and that's a 1. That's actually kind of not a coincidence. Okay, so now I plotted this point. Let's plot this point. 1, 2. Okay, now let's plot this point. 2, 5. And if I come over here, I've got negative 1, 2. And I've got negative 2, 5. Now, can you see how the picture is symmetrical? I've got like a center point, and then these are exactly equidistant from that center line. So the graph is what's called a parabola. It's a gentle curve. And it looks like that. Now, if I were actually up at the board, you would see a much prettier shape. It's a U shape looking like this. Okay, it's a U shape, and it's symmetrical, and it should be all pretty and perfect. Now, when you draw it on your paper, you can't get it pretty and perfect, and you can't use a ruler because it has to be a gentle curve. But that is what a parabola is. So do the best you can to make it look good. Okay, our third family is called an inverse function. X's variable is x variable's exponent is still a 1. See, I have a 1 here. The graph is what's called a hyperbola or inverse. We'll get to that shape in a moment. It's undefined at 0 because we can't have division by 0. If I put a 0 in for x here, you notice how 8 divided by 0 won't work? That's how we get undefined. The other thing you need to notice is that as x values go up, the y value decreases by division. Okay? You'll see that in a moment. So here's the one we're going to graph. Y equals 8 over x. This one is an inverse function. All right, it's obvious to see this one. The rest maybe not so much. So if I put a negative 2 in, I get y equals 8 divided by negative 2. 8 divided by negative 2 is negative 4. If I put a negative 1 in, I have 8 divided by negative 1, which is negative 8. If I put a 0 in, I have y equals 8 over 0. When you see any division by 0, you should freak out. Undefined. Can't have anything with a 0 in the denominator. If I put a 1 in there, I have 8 divided by 1. Okay, so that's this one here, by the way. And that's a big clue that it's an inverse function. 8 divided by 1 is 8. 8 divided by 2, 4. Okay, this one looks kind of symmetrical, only it's not, because these are positive values and these are negative values. Whereas the squared in the parabola, the squared term got rid of your negative, which made it exactly the same value on either side of that center point. This one has negative values and positive values. Now, if I go to graph this, I can't graph anything along the y-axis because it's undefined, so there is no y-intercept. But 1, 8 is here, 2, 4 here. And if I kept going, let's say, I'm not going to use 3 because 8 doesn't divide by 3, but I could do a 4, 8 divided by 4, which would give me 2, so 4, 2. I kind of need a few more points to get going on this. If I did 8 here, what would I get? 8 divided by 8 is 1. So what I actually get is this shape here. It's a gentle curve also, but it will never hit 0. You will never get y to equal 0, because in order for y to equal 0, you'd have to have a 0 in your numerator, and I already have an 8 there. So it never hits 0 on the y-axis, and it never hits 0 on the x-axis. If I do my negative values, I'll have negative 1, negative 8, negative 2, negative 4, and it's going to be the same here. If I have negative 4, I'm going to have negative 2, and negative 8, negative 1. It's just going to be kind of a mirror image of this. So negative 4, negative 2, negative 8, negative 1. And again, my pen is not great, so it's kind of like a nice little U and a nice little U, and it will never hit the axes. Okay? So as the x values go up, the y values decrease by division. Okay? And this is what's called a hyperbola. It always looks like this. Okay? All right. So now, fill in each of the tables with the given function. Describe the family to which each function belongs. This is what they ask you to do in the lesson. So basically, you're plugging in your x values and getting your y values. So 4 divided by x. So x is negative 2. 4 divided by negative 2 is negative 2. 4 divided by negative 1 is negative 4. 4 divided by 0, alarm should go off, it's undefined. 4 divided by 1 is 4. 4 divided by 2 is 2. What family does this belong? Well, you could say inverse, or you could say hyperbola. Okay? And that's what you're going to be asked to do in the lesson. How about this one? There are some big clues here. We could figure out what the y values are. Okay, so 2 squared plus 3, that gives me 4 plus 3 or 7. Negative 1 squared plus 3, that gives me 1 plus 3, 4. 0 squared plus 3, that gives me 3. 1 squared plus 3, that gives me 4. 2 squared plus 3, that gives me 7. Notice the symmetry in my data values. Notice the squared. That's got to be parabola. Parabolic or quadratic. Either word, you don't need both, one of them is fine. Finally, y equals 2x minus 1. Hopefully you see it and you can tell which one it is. If I plug in negative 2, I get negative 4 minus 1 or negative 5. If I plug in negative 1, I get negative 2 minus 1 or negative 2. If I plug in 0, I get 0 minus 1 or negative 1. If I plug in a 1, I get 2 minus 1 or 1. If I plug in a 2, I get 4 minus 1, which is 3. This one grows steadily by 2. The slope is 2, the intercept is negative 1. This is a linear function. Okay? All right, finally, the very last thing they'll ask you to do in this lesson is they'll ask you to look at the chart. They give you the pairs. Analyze the tables, then write the equation that matches the data in the tables. Describe the family to which each function belongs. Okay, so this is the last thing that they ask you to do. So I look at the values here. This is growing by 1. What's happening to my y values? Looks like I'm adding 2, adding 2, adding 2, adding 2. That's steady growth. Oh my, it must be linear. So if it grows by 2, that means that I've got to follow y equals mx plus b. My m has to be 2. Where do I find my b? Right here, 12. So my b is 12. So when I write the equation, I get y equals 2x plus 12. Linear. Okay, next one. Let's look. I'm growing by 1 in my x values. What's happening in my y values? I've gone from 3 to 0. Okay, that's like minus 3. So this could be inverse, but it could also be parabolic, or it could be linear, right? So then I grow by -1. Okay, well, it's not consistent growth. And then I've got 0 again. Uh-oh. And then I've got 3 again. Oh, I see it. The symmetry. Do you see the symmetry? The 3 and the 3, the 0 and the 0, and then this being my center. So this one must be parabolic. Okay, so I know it's going to be something with an x squared. So I know it's something like x squared. So now let's look at it. If I have an x is 0, I put in 0 there, y would be 0. So it seems like it would be that squared, maybe -1. Let's try that. If I put 0 in here, does it work? 0 squared minus 1? Yes. If I put a 1 in there, 1 squared minus 1, 0? Yes. If I put a 2 in there, 2 squared minus 1, 3? Yes. Got it. Okay. Last but not least, you probably can predict what it's going to be, but let's just look at how how you would know. 1, 2, 3, 4, 6. Oh, I skipped a 5. Interesting. What's happening to my values here? I go to 6, I go to 4, I go to 3, I go to 2. It's shrinking, but not by the same amount every time. I don't have symmetry in my data. This is probably going to be inverse. So I'm thinking about y, I'm thinking about x in the denominator, and I'm wondering what's on top. So let's figure this out. If I do divided by 1, I get 12. If I do divided by 2, I get 6. If I do divided by 3, I get 4. I think it might be y equals 12 divided by x. 12 divided by 1 is 12. 12 divided by 2 is 6. 12 divided by 3 is 4. That works. What is it? Inverse or hyperbola. Either one would work. Okay? So that's a lot of information. Good luck.